Lesson 3 is our third of 3 lessons on number, and let's start with operations with signed numbers. So plus or minus sign is what we're talking about here. Now in algebra we'll work with both positive and negative numbers. And to simplify operations in algebra, it's a little easier to eliminate subtraction and just think add a negative number instead. So look at these examples here. Instead of 6 minus 3, think 6 plus a negative 3. You can also think of it as 6 plus the opposite of 3, because that's kind of what's happening with a negative number. It's the opposite of the other number. Instead of 82 minus 41, think 82 plus a negative 41, or 82 plus the opposite of 41. And in algebra, we're working a lot of times with letters instead of numbers, or in place of numbers. So instead of x minus y, think x plus a negative y, or x plus the opposite of y. So that phrase there, the opposite of, that's an important phrase to think about when you're thinking of negative numbers. Now we did this a little bit in lesson 2. Maybe you remember example 2.7b. What we want to do here to turn a subtraction problem into an algebraic addition problem, we'll use a similar procedure. We'll first group the negative sign inside parentheses together with the number that's next to it. Then we'll put a plus sign to the left of that. So let's look at an example here. Example 3.1. Use parentheses to group each number and its sign. Then insert plus signs as needed. Add to get a sum. So we have negative 4. Let's just put that in parentheses. Anytime we see a negative number, put it in parentheses. That's a good practice to get into as you do algebra. It just helps you keep up with that negative sign. That's probably one of the #1 things students get wrong on a problem is they just have a plus or minus sign mistake somewhere. It's a little simple mistake. So it's important to stay organized and just get in the practice of keeping up with your negative sign. So we have a negative 4 plus, and we can say positive 7 on the inside, and then minus 6 we'll say plus a negative 6. So we're adding a negative 6. Now let's add a number line to this and just think about how this will work out on a number line. And so we start at 0 always on a number line, and then we'll add a negative 4, so we'll go this way. Then we'll add positive 7, so now we go back this way, 7, and that gets us to that 3. Then we're going to add a negative 6. So we go in the opposite direction. So the opposite of positive 6, we go in the opposite direction there, and we end up at negative 3. So maybe you remember from example 2.7b, the first 2 numbers there, the first 2 digits we added, that's what we did in example 2.7. And then we just added a negative 6 to that. Now obviously we don't want to have to get out a number line every time we want to add one of these systems together. So now let's just think about adding, and add in pairs. It's always a good idea to add in pairs. So we'll just go 2 at a time here. So we have a negative 4 and that 7. Let's add those together, and that would give us a positive 3, and then plus that negative 6. And so then just adding those 2 things together, that gets us a negative 3. And so that's our result there. So just reviewing there, we thought of that negative 4 by itself, the plus 7 by itself, the negative 6 by itself. We put those in parentheses and then put plus signs in between to make it into algebraic addition. Let's do a couple more examples here. Example 3.2, let's do that, and use parentheses to group each number and its sign, then insert plus signs as needed, add to get a sum. So like we did at the end of example 3.1, let's just circle these. That's what we're going to put parentheses around: the negative 4, the plus 7, the minus 6, and the plus 9, and we'll put plus signs in between. So there's our 4 numbers with parentheses around them and the appropriate signs, and add in pairs. So let's add that pair and this pair here. So we have a negative 4 plus 7. that's a positive 3. Keep that in parentheses. Plus a negative 6 plus a 9, so that would be another positive 3. And so then just adding that pair together, it would just be 3 plus 3 is 6. Now, eventually you're going to want to stop using all those parentheses. I mean, it just takes more time, takes up more space. It's a little messier too, just having so much information on the page. So one thing we want to do is insert parentheses mentally to group each number and its sign, and then add algebraically. So always add in pairs, showing your work as you go. So let's add in pairs. Let's add that 4 and 7, or negative 4 and 7. Let's add the negative 6 and 9, and then that negative 11, we'll just bring that down. So negative 4 and 7, we know that that's equal to positive 3. Negative 6 and 9 is also a positive 3. And then just bring the negative 11 down. So let's add in pairs again. So we have plus 3 is plus 6. Bring the negative 11 down again, and that would give us a negative 5. So you can get rid of those parentheses eventually. It's good to do them like example 3.1 and 3.2 to start with. But you can see we can just think of this pair. Okay, I'm adding that pair, that negative 4 and that positive 7. And then I'm going to add this pair, that negative 6 and that positive 9. And then I'll have that negative 11 just to bring down. And eventually I'll have a pair with it. But for now, just add the others together. Let's look at operations with signed numbers and multiplication and division now. And please review the rules for multiplication and division. Those were in your rules and definition section, so make sure and look over those. You should have done that already, but you may want to go back and review them. And so when you see a negative sign, think the opposite of. We talked about that earlier, but that phrase, the opposite of, that is important to think about negative numbers like that. So, for example, negative 3, that means the opposite of 3. Minus a negative 3, therefore, means the opposite of 3, or just positive 3. Think about what we just said there on a number line. Start at 0, go to negative 3. Now what is the opposite of that? Well, that would be over here, right? The opposite of negative 3, or the opposite of 3. That's a positive 3. A simple way to remember it is that negative times negative, that equals a positive. Now look at that last example there. Negative times negative times negative 3. That means the opposite of the opposite of the opposite of 3. So if we look at our number line again, we have on there, we have the opposite of 3. Add another opposite of 3. That gets you back over here. That's a negative 3. We can make sense of that on the number line. We kind of see how that works. That's why the number line's helpful here. Something else to notice is that when you have an even number of negatives multiplied together, you get a positive result. If you have an odd number of negatives, you'll get a negative result. It doesn't have to just be 3, but if you had 5 negatives in a row, 7 negatives, 9 negatives, and so on, that would give you a negative result in the end. Or if you just had one negative, if you had negative times positive, that would equal a negative result. So would positive times negative. It doesn't matter what the order is, it gives you a negative result. And then, of course, positive times positive, that's going to give you a positive result. Division actually works the same way. So if you have a negative over a negative, that also equals a positive result. If you had a negative over a positive, that's going to give you a negative result. If you had a positive over a negative, that will also be a negative result. And if you had a positive over a positive, that gives you a positive result too. Notice how we're thinking of operations with signed numbers, both addition, subtraction, and multiplication, division. We're thinking of this in pairs. That's a very good way to think about it. So if you have a problem that has 3 or more multiplication, division parts in it, break it into pairs. Let's do some examples now, and let's do A and B together. And it's important to see the difference here between these two. A is saying the opposite of 3 times 4. So there we want to just do 3 times 4, so we just write 12 down, and then we put the opposite of, so it's negative 12. So that's different than B. B is saying the opposite of 3 4 times in a row. So it's basically it's saying negative 3 plus negative 3 plus negative 3 plus negative 3. That's a little bit different way of thinking about it, and that'll be important later when you're thinking about negative numbers and doing bigger operations. But the result is the same. It's still negative 12. It's just kind of a different way of getting there. In A, it's saying 3 groups of 4, which is 12. Well, what's the opposite of that? B is saying 4 groups of negative 3 each. C, let's just think of our pair of unlike signs there. That means that we'll have a positive result, so that will just be a positive 12. And we don't have to put plus in front of it. We'll just write 12 down. It's understood if there's no plus sign in front of it that it's a positive result. D, we have negative 9 over 3, so we have unlike signs there, a pair of unlike signs. So we just think, well, 9 over 3, that's equal to 3. It's going to be the opposite of that, though. It's minus 3. And then E, again, we have unlike signs there, so that will also be minus 3. And then F, we have like signs, so the answer should be positive. That would be a positive 3 or just a 3. Work in pairs on these. Like signs yield a positive result. Unlike signs yield a negative result. Let's move on now to part B and absolute value. And the most important thing to understand about absolute value is that absolute value has to do with the number, not the sign in front of it. So when you see like these vertical bars around a number, that means find the absolute value. So remember, mathematics is a symbolic language, and so those bars, they have a meaning to them. They mean find the absolute value. So instead of writing a whole sentence out saying find the absolute value of negative 3, you just have negative 3 and 2 bars. Now think about this also, just a 3, or I'll put a plus sign in front of it just for clarity here, a positive 3. Both of those equal the same thing. They both equal 3. So one good way to think about absolute value is to use a number line. And so positive 3 is right here. Negative 3 is right there. How far away is that positive 3? How far is it from 0? Well, it's a distance of 3 away, right? Well, so is the negative 3, right? It's also 3 away. That's like if we took a ruler and we measured the length, we'd say it's a length of 3. So relative to 0, the negative 3 is to the left of it, and the positive 3 is to the right, relative to 0. But the absolute value, the distance there, that's what the absolute value, that's a way to think about that. It's 3 for either one. They're equal to each other. So we're not talking about relative value here. We're talking about absolute value. So there's a difference there. So let's do those example problems there. Find the absolute value for each of those. So A, well, that's just going to be 6. And so is B. That's going to be 6 as well. That's the absolute value. C, we need to do a little bit of addition first. So we have a 2 plus a negative 6. So we're saying the absolute value of negative 4, that equals a positive 4, or just 4. And then D, a little more math on this one to do. let's do what's inside the absolute value sign first. So we'll say 3 minus 2 minus 6, that's what we just did in C, so that's 3 minus 4. Let's back up a little bit though. Let's put the absolute value bar in the negative 4 right there. And so it looks like 3 minus a negative 4, doesn't it? Those aren't parentheses though. We don't do negative times negative is positive there. We take the absolute value first. So the absolute value of negative 4 is 4, so we just say 3 minus 4. So there's a difference between the absolute value bars and what you do with that and parentheses. And then 3 plus a negative 4, or 3 plus the opposite of 4, that would be a negative 1. And so D is equal to negative 1. So absolute value, it has to do with the number and not the sign in front of it. Let's move on to part C and order of operations and exponents. And let's look at order of operations first. And let's say, for example, you had this 2 times 3 plus 4. In a problem, you're asked to solve that. Well, do you do 3 plus 4 first, like this part? 3 plus 4 is 7, then times 2 is 14. Do you do that first? Or do you do the 2 times 3 first and get 6? Plus 4 is 10. One way you get 10 for an answer, the other way you get 14, so you get different answers. Well, the way that I show there, that's the correct way. And just think if people in China or Russia or somewhere, they did the addition first, then the multiplication, and we did multiplication first, then addition, that would get really confusing. Fortunately, everybody does it this way. Multiplication is done first on a problem like that. Now look at this here. If the problem also involves symbols of inclusion like parentheses, absolute value bars, things like that, whatever operations are inside the symbols, those should be performed first, followed by multiplication, division, and then finally addition, subtraction. Or we can just think of algebraic addition, adding things, adding plus the opposite of. Another important concept is exponents. Let's think about just an example with numbers. 4 times 4, that's the same thing as saying 4 squared. 4 times 4 times 4, 3 times, that would be the same thing as 4 cubed. So that's what an exponent does. See how it's a lot faster to write this than it was to write 4 times 4 times 4. More of that language of mathematics there. If you understand what the little 3 means there, then this is easy. You understand that, oh, we're doing 4 times 4 times 4 there. So use letters instead of numbers now. X squared, that's the same thing as x times x. X cubed, that's the same thing as x times x times x. X to the 4th is 4 x's multiplied together. X to the n is n values multiplied together. So that's how that exponent symbol works. So let's do some practice problems now. Let's simplify here. Look at A. 4 squared plus 6. So 4 squared, that's a multiplication, right? So we want to do that first. So that would be 16. And then let's add the 6 to that. And that would give us 22. And then look at B. Similar to A, we just added something on there, that 3 minus 1 in parentheses. Remember, we want to do that first. So with exponents, it's okay just to write down the 16 instead of the 4 squared. But then we'll want to say plus 6. 3 minus 1, we do that first. 3 plus the opposite of 1 is equal to 2. So we have a multiplication in there still. We have 6 times 2, so we want to do that before we do any addition. So we'll say 16 plus 6 times 2 is 12. Now we'll add that pair and get 28. So that's our answer there, 28. C, let's do that. Again, we have a 4 squared. We have some parentheses and absolute value now also. So we can write that 16 down. That's okay to do that multiplication first. Then we'll say plus 6 times 2. Then let's take the absolute value of negative 7. That would just be a 7. So we have that as well. Now let's do our multiplication before we do any addition. 16 plus 12 plus 7. Let's add in pairs now. We have 3 things to add. So we do the 16 plus 12 is 28 plus 7. That equals 35. So show your work on your paper as you do a problem like this, like I have there. Add in pairs, stay organized. Notice how I kind of keep things lined up here. I keep that 16 lined up, and then the 6 and 2 part, that's all lined up. The 7's lined up. So things kind of flow smoothly and you can stay organized that way. And then you don't have to put these lines in here showing that you're combining that pair of numbers, but you can if you want to. Symbols of inclusion first, then multiplication, division, then addition. Okay, well that's all for lesson 3.